Hello everyone. We have had some problems in the last session, and in this session I take more illustrations. They would be different from the previous one, but they also are not going to be so simple ones also. And from examination point of view, they would be of some help. Now I start with first as a plus b plus c is given to be pi, and then sigma tan b upon tan c plus tan c upon tan b equals, and then we are given four options. Now, when I read this, I understand that I have to start with a plus b plus c. And since four options are in terms of sec, and we have not done any formula on sec, so I start with cos. And I write cos a plus b plus c equal to cos pi. And cos pi is minus 1. And I straight away apply formula of cos a plus b plus c, which you have already done. And that formula is cos a cos b cos c minus, then you write three terms, and each one of them would be of the form 2 sine and 1 cos product. And the expression is something like this. Now, what I do, since I have to arrive at sec, so I divide by cos a cos b cos c, and I get minus sec a sec b into sec c equal to 1 minus, and then inside bracket, sum of the products taken two quantities at a time, tan a tan b tan c, and tan c tan a. Their sum written inside bracket. I hope everyone understands how do I get that. That I get after dividing by cos a cos b cos c. And I realize that I can still further simplify and keep ready the expression for sigma tan a tan b, or you can call it sigma tan b tan c. When I say sigma, that means there would be three terms, tan a tan b tan c, and tan c tan a, their sum. And that turns out to be 1 plus sec a into sec b into sec c. So these are three terms product. So if you wish, you can call it product sec a. I mean, when you talk. Now this I keep ready, and I look at the given expression. And the given expression is sigma tan b upon tan c plus tan c upon tan b. Now there would be two more such brackets. I mean, tan b upon tan c appears and its reciprocal appears. Now I try to write those six terms in a different way, and I write it as tan a plus tan b upon tan c, and now two more similar looking terms. When I say similar, that means a and b I have written at the top in the numerator, then b and c combination in the numerator, and then c and a combination in the numerator. And I further simplify it, and I write now in sigma notation. I hope you understand that. Now tan a plus tan b upon, and denominator is tan c, that I will write as tan of pi minus a plus b, and tan pi minus theta is minus tan theta. So this becomes minus times sigma tan a plus tan b upon tan a plus b. Now tan a plus tan b and tan a plus b you have seen in one formula, and that formula is what? Tan a plus b. It is tan a plus tan b upon 1 minus tan a tan b. And from there, I rewrite the expression for sigma tan b upon tan c plus tan c upon tan a as minus times sigma 1 minus tan a tan b. Now see the bracket. That bracket and sigma is outside. That means sigma would apply on that 1 also. And that leads to sigma of tan a tan b minus 1. Then that sigma, when you apply on that 1, you will have minus 1 three times. So on simplification, you will have sigma tan a tan b minus 3. And what is sigma tan a tan b? From the equation 1, it is 1 plus product sec a, right? And that I substitute, and then I get product sec a sec b sec c minus 2. And that is the expression for the required one. So what is the correct answer? The correct answer is option A. I hope I'm clear to you. Now I move from here to the next one. And the next one is a regular pentagon is inscribed in a unit circle. Let A represent the side length and B represent the diagonal length. Then product AB is. And what do you think? What we will have to do? We will have to draw the figure first. That a regular pentagon is inscribed in a circle and side length is given as A. So length AB would be A, correct? And unit circle means radius is 1. And I have shown M as midpoint of AB in the picture. So I write certain things from there. I write length AB is A, which is 2 times AM. I hope everyone finds that. Now AM, can it be written as sine pi by 5? because AB would subtend angle at the center as 2 pi by 5 and half of that is required in triangle AM, and if I call center as O, then in triangle AMO, angle AOM would be pi by 5 and hence AM is sine pi by 5 because radius is 1. So from there I have found length AB. It is 2 sine pi by 5. Fine. And what about AC? Now when AC subtends angle at the center as 4 pi by 5, similar exercise we will do and we will get answer for AC as 2 sine 2 pi by 5, which from the given questions information is to be kept as B. And product AB we have to find, and that is nothing but 4 sine pi by 5 into sine 2 pi by 5. Now break that 4 as 2 into 2. So it would be 2 times 2 sine pi by 5 sine 2 pi by 5. Apply 2 sine A sine B formula and simplify that further as 2 times cos pi by 5 minus cos 3 pi by 5. Now this is of the form further as, like if you want to write in degrees, then it is 2 times cos 36 degree minus cos 108 degree. Now can I write that cos 108 degree? That is 108 degree means 180 minus 72, right? So cos 180 minus theta is minus cos theta. So this is 2 cos 36 degree plus 2 cos 72 degree. Now the thing is, we do not know answer for cos 72 degree, but we know for sine 18 degree. So cos 72 degree is sine 18 degree and that is the standard value as root 5 minus 1 upon 4, and cos 36 degree is a standard value and that is root 5 plus 1 upon 4. Substitute these values and then simplify it further to get answer as root 5. So the correct option is A. Now this question was again different from the previous one. Now here we have applied the trigonometry part in the geometry one. Fine. Now move to next. And the third one is that if tan alpha plus beta minus gamma upon tan alpha minus beta plus gamma is given to be tan gamma upon tan beta, then we have to find sine 2 alpha plus sine 2 beta plus sine 2 gamma. And some 4 options are given. Now recall that we have done when we were doing formulae that some identities can be taken here onwards as formulae. And one of them was tan A plus tan B upon tan A minus tan B. Stretch your mind, you will get answer. That was in terms of sine. That perhaps I'll be using here. So I start with tan of alpha plus beta minus gamma upon tan of alpha minus beta plus gamma. This is tan gamma upon tan beta given. Then I apply componendo dividendo because I have in my mind that I am going to use that tan A plus tan B upon tan A minus tan B. So I use componendo dividendo. Now this is perfectly suitable for that formula. And that formula was, could you get by now? That was sin A plus B upon sin A minus B. Right? So right now this expression in terms of sine. And I get that as on the right hand side sine gamma plus beta upon sine gamma minus beta. Right? And further you simplify and you will get lastly sine 2 alpha upon 2 cos beta minus gamma equal to minus times sine beta plus gamma. Now multiply that 2 cos beta minus gamma and try to simplify it further. Now right hand side becomes minus 2 times sine beta plus gamma cos beta minus gamma, which is of the form 2 sine A cos B. Now mind you please, left hand side is sine 2 alpha and that I am not going to disturb. I keep that as same and then further use formula of 2 sine A cos B and that leads to minus times sine 2 beta plus sine 2 gamma. For right hand side I am saying, and you are there. You get sine 2 alpha plus sine 2 beta plus sine 2 gamma as 0 and the correct answer is C. Right? Now should we move to fourth one? Now see, this question was again different from the previous one. Here we did use formula, but then that formula should occur to you that from tan if you have to reach to sine, then that formula is to be used. Okay, let's move to the next one. And the next one is the value of tan 6th pi by 9 minus 33 times tan 4th pi by 9 plus 27 times tan square pi by 9. That we have to find. Now this question is very, very, very different from the previous ones. Now here you will have to develop your skills. And what type of skills? That you should be able to club trigonometry and algebra. Now here when I see that tan 6th pi by 9, tan 4th pi by 9 and tan square pi by 9, I try to treat this as a cubic polynomial in tan square pi by 9, right? Okay. Now pi by 9 otherwise is not so friendly angle, but 3 times of pi by 9 could be friendly angle. So I proceed like this. I take alpha as pi by 9 and then two values I have written on my own, 2 pi by 9 and 4 pi by 9. What makes me write that? Then I can tell you this, that leaving 3 pi by 9 and leaving 6 pi by 9, leaving 9 pi by 9, any other angle I would have written here, right? Stretch your mind and get your answer that why I am saying leaving pi by 9, leaving 3 pi by 9, etc. Fine. Now what I do, I go for 3 alpha from here and I get those standard angles like pi by 3, 2 pi by 3 and 4 pi by 3 respectively. Look at the expression at the top. It is going to be a cubic polynomial and hence I have gone for 3 alpha. Keeping in mind that I have to get tan 3 alpha because cubic term in tan alpha appears only in tan 3 alpha. So I go for tan square 3 alpha. Why do I go for square? Because it is required in the expression. So tan square 3 alpha, if you go for, then tan pi by 3 or tan 2 pi by 3 or tan 4 pi by 3, they all on squaring will give you plus minus root 3 square. They will give you 3. So tan square 3 alpha is 3. Now substitute formula for tan 3 alpha, that is 3 tan alpha minus tan cube alpha upon 1 minus 3 tan square alpha whole square equal to 3. Now simplify this and you will get 1/6 degree expression on the left, that is tan 6 alpha minus 33 tan 4 alpha plus 27 tan square alpha, and the constant one I have kept on the right only because all those coefficients are also matching. That minus 33 is already there, 27 is already there. That means you have already found your answer, and answer is nothing but 3. So the correct option is B, realizing that it is a cubic equation in tan square pi by 9. Mind you please, with help of this, I could have answered many other questions which could have been in the form of tan 2 pi by 9 or tan 4 pi by 9 or combination of tan pi by 9 and tan 2 pi by 9. So method is important, that you had to generate a cubic equation in tan square pi by 9. That is the crux of the problem. Now, this method is divine, very, very different from what you have learned by now in trigonometry. And this is what I wanted to take at the end. Now, here we actually finish our sessions on trigonometry. When I meet you next time, I will come again with some new topic. Till then, stay tuned. Thank you.